Hello, let's get into simplifying radicals. When simplifying radicals, consider these two things: being able to list the factors of a number, or recognizing and using the perfect squares. If you don't know what the perfect squares are from at least 1 through 20, here they are. They're very useful if you can memorize them. But if you can't, do the best you can on the test. Let's start simple and small. Square root of 12. List out the factors to the side. So we have 12, 1 times 12, 2 times 6, 3 times 4. 4 is a perfect square. And so I'm going to choose this pair of numbers of factors because the 4 is a perfect square. Why is that important? Because we really want to max out and reduce square root with the highest perfect square that we can have in the list. So I'm going to rewrite my expression split into 2. Square root of 4 comes first, and then square root of 3. I always write the perfect square first, simply because it's going to get simplified in our next step. The square root of 4, according to the chart to the left, is 2, and square root of 3 just gets brought down. Okay, we're done. Let's see that again. Square root of 18, list the factors out to the side. 1 times 18, 2 times 9, 3 times 6. Where is the perfect square in this list? Did you choose 9? In this case, 9 is our perfect square. Actually, it's our only perfect square in this list of numbers. So we're going to rewrite the expression and split the square root of 18 into 2 smaller ones. Square root of 9 first, square root of 2 second. Then you're going to simplify just the perfect square part, which is square root of 9. Square root of 9, according to the chart to the left, is a 3. So square root of 9 is 3. Square root of 2 gets brought down. It does not get reduced. It's as small as it can be for a square root. And we're done. Here's a bigger number, 294. Well, let's get cracking on these factors. 294, 1 times 294. Let's see, 294 is an even number, so I should be able to divide it by 2. 2 times 147, okay. If I add up my numbers, 2 plus 9 plus 4, the digits, that adds up to 15, so I should be able to divide it by 3. Okay. Based on the rules of divisibility, if a number is divisible by 2 and 3, usually I can do a 6. I'm going to jump to a 6 and let's see what we get. Oh, there's our perfect square. 49. In this case, 49 is our perfect square, so that is what we're going to split 294 into. Square root of 49, square root of 6. Remember, I always write the perfect square first because it's going to get simplified to the answer off to the left off the chart, which is a 7. And there you go. Nothing can be done further to the square root of 6. Just a tip. I'm not sure whether I listed all the factors of 294. It's not necessary for these problems. You're really just factoring until you find a perfect square. Another tip is that you're probably wondering, how did I figure out how the factors of these big numbers? Well, like I said, I used the rules of divisibility and simple mental math just to divide in my head. Let's move on to the next problem. Square root of 600. I'll give you pause the video so you can try this on your own to see if you can come up with all the factors and figure out which pair to split this into. Resume the video when you're ready. Let's list out the factors. 600. Woo, that was a lot. Well, choose the pair of factors that includes a perfect square. Again, I always stop my list of factors once I hit the pair with a perfect square in it. And in this case, it's going to be 100. So rewrite your problem. Square root of 100 comes first, square root of 6 second. And what's the square root of 100 when you simplify? It's just a 10. Square root of 6 comes down as is, untouched. And we're done. What about this one? There's a 4 lingering outside the square root house. What do I do with that one? Well, nothing at first. Right now, we're going to concentrate on just the square root of 8 and breaking it down to something smaller. The 4 is just going to stay off to the side for a little bit. Let's list out the factors of 8. That was quick. Is there a perfect square in this list? Of course there is. And it's going to be 4. It's small, but it's still a perfect square. So we're going to split up the square root of 8 into 2, square root of 4, and then square root of 2. Again, I always write my perfect square first when I do the split. So what's the square root of 4 again? Yes. It's going to turn into a 2. So remember that 4 that was with us from the beginning of this problem? Now I'm going to multiply it with the 2 that sits outside the other square root of 2. And that'll give me 8. Pause the video if you need to go back and re-look at this further. Let's try another one. 2 square root of 27. List out the factors of just the 27. Stop when you hit a perfect square number, which is 9 in this case. Rewrite your expression and using the factors with the perfect square coming first. Simplify the square root part. Multiply your numbers that are outside the square root. And you're done. Here's one that's different. This one has a division problem, or maybe you could say it's a fraction underneath the square root. Well, recognize that you have 2 perfect squares in this particular problem, 49 and 100. But we can work this problem out 2 different ways. So I'm going to repeat the problem twice and go down in columns. We got method 1 and method 2. Under method 1, I'm simply going to do 49 divided by 100 and just do the square root of each of those numbers, which comes out to be 7/10. The other method is where I split each of the numbers and give them their own little square root house. But in the end, when you do square root of 49 by itself and square root of 100 by itself, it still comes out to be 7/10. You get the same result. Let's do it again, but this time neither of the numbers are perfect squares. In this version, both the numbers are already split. So you might be tempted to combine this one into one and then reduce the fraction, right? Try to resist that. It's not a good idea. So focus on breaking down the denominator. Sorry for the typo. 12, list my factors. My perfect square is the 4. I'm going to split up the square root of 12 just on the bottom into square root of 4 and square root of 3. And simplify your perfect square which is square root of 2 over 2 times the square root of 3. Okay, please understand you can divide square roots by square roots, but they have to match. Meaning I could divide square root of 2 only if there was another square root of 2 on the bottom, but I can't do it when the numbers don't match under the square roots. Try these radicals. Pause the video, try them on your own. Resume the video when you're ready to work. Okay, let's see these two different methods. I have the first method that I call the combine and simplify. This is when both the numbers are under the same square root house and you just work it as is. The second method, under this first problem, you're unable to reduce this fraction. 27 divided by 16 under any other circumstances is not able to be reduced. So this first method is not going to work on it. Method 2 is where we split and simplify. That means each number, 27 and 16, get their own little square root house, and you deal with them accordingly. Square root of 27 is the one that we really have to work on because it needs to be split up into two smaller ones. Square root of 16, you guessed it, is an easy one. You already know what that answer is. So let's go ahead and simplify the top and the bottom. Square root of 9 turns down to a 3 with the square root of 3, and the bottom automatically turns into just 4. Square root of 16 is just 4. We're done. Let's look at the second problem. You can combine and simplify on this one, which means putting the numbers under the same house. We could reduce this one, but don't mistake these for regular fractions. You don't want to reduce it down too low to where you can't deal with it. So we're only going to split it down to like a 9. So I'm going to divide 18 and 36 both by 9, and that should get me square root of 2 over square root of 4. If I split it up, I get square root of 2 on the top and square root of 4 on the bottom. When I simplify, just the bottom balances out to just a 2. If we kept it split, it would have went this way, square root of 9 and square root of 2, because square root of 36 is a perfect square. Simplify, you still get 3 square root of 2 over 6. But see that 3 and 6 part? I can still reduce that because those are just numbers. And that still gets me to the same answer. 3 over 6 is just, it reduces down to 1 over 2 at the end. Let's try the last one. 80 divided by 5. If I do the math off to the side, 80 divided by 5 actually turns into 16. And do you know the square root of 16? You guessed it, it should be a 4. Well, let's keep the two problems, original problem back in split form. So square root of 80 split down into two factors would be square root of 16 and square root of 5. Look at that. My square roots finally match where I can cancel those out, which would just leave the square root of 16, which will give us an answer of 4. Well, I hope you learned something. Thank you for watching.